Hey everyone! In this video, we're going to be talking about the fundamental theorem of calculus and how it relates to definite integrals. So, as you can probably tell by the name, the fundamental theorem of calculus is pretty important in the world of calculus. And although it is an important theorem, that doesn't mean it's complicated. It's actually quite simple. So, to understand it, let's look at what I have written in the corner here. This is the fundamental theorem of calculus. But before we jump into it, let me define a little bit of notation for you. So our original function is going to be denoted with a little f of x, and our antiderivative function is going to be denoted with a capital F of x. And this line with a to b here just means that we're recognizing that we have to evaluate our antiderivative from our limits of integration, the points a and b, which are written up right here. Okay, so the fundamental theorem says if we're taking an integral from point a to b of a function f of x with respect to x, then the value of that is equal to our antiderivative evaluated from point A to B. And in order to evaluate it, we use the fundamental theorem of calculus. And all that says is that we take our antiderivative, evaluate it at point B, and then subtract our antiderivative evaluated at point A. And that's it. That's how we use the fundamental theorem. So, to summarize, we take the antiderivative of our function f of x, recognize that we have to evaluate it from points b to a, and then use the fundamental theorem, which says we evaluate our antiderivative at point b and then subtract our antiderivative evaluated at point a. So to really solidify how this works, let's look at some examples. So example 1 says, evaluate the integral from 1 to 3 of 1 over x dx. So the first thing we need to do is take this antiderivative. So we know the integral of 1 over x is equal to the natural log of the absolute value of x, and we need to recognize that we have to evaluate this from points 1 to 3, because in this case a is 1 and b is 3. So by the fundamental theorem, all we have to do is plug in those values, and that's going to give us the value of our antiderivative. So we have the natural log of 3 minus the natural log of 1. And if you recall from algebra, whenever we have a difference of natural logs, we can combine them as a quotient. So this equals the natural log of 3 over 1, which equals the natural log of 3. And if we plug that into a calculator, it's going to approximately equal 1.099. And that is how we use the fundamental theorem of calculus. Okay, now let's look at example number 2. Example 2 says, evaluate the integral from 0 to 1 of 2 times e to the x dx. So the first thing to notice is that we have a constant 2 here. Whenever we have a constant, we can always pull that outside of the integral. So this is going to equal 2 times the integral from 0 to 1 of e to the x dx. So now we have to evaluate our antiderivative. So the antiderivative of e to the x is itself, and we need to recognize that we're going to evaluate it from 0 to 1. So now we can use the fundamental theorem of calculus and see what our numerical answer will be. So we have to multiply it by 2, so that's the first thing I'm going to write, and then separate our integral off by brackets. So the fundamental theorem says, take your function evaluated at point b, which in this case is 1, so we're going to have e to the 1 minus it evaluated at point A, so e to the 0. And that's it. That's all we have to do. If we take all this and plug it into the calculator, and then multiply it by 2, we'll see that this approximately equals 3.44. And that's it for example number 2. So these are some basic examples of how we use the fundamental theorem of calculus with definite integrals. It is a critical part of calculus, and it's a very helpful theorem. I hope this video helped it make sense to you, and thanks for watching. If you thought this video was helpful, please subscribe, like, and share with your friends.